Hello, and welcome to Theme Thursday here on Answer Everywhere. Today we're taking a look at Rules Haskell, some Bazel build system integration rules for Haskell. This continues our ongoing theme of Haskell build systems. In the past, we've looked at the Hadrian build system for GHC, and also Cabal and Stack. And we've also, in the past, separately from the Haskell ecosystem videos, looked at Bazel. And so this episode is going to merge the Bazel stream with the Haskell stream and give us a sense of how we might build our Haskell projects with Bazel. So they have a nice website, which you can check out, including a user guide and documentation. But in our time-honored tradition, we're not going to read the docs. We're going to just jump straight into the code. So I have the GitHub open. And maybe before I begin, I'll give the usual proviso that one, I'm not a Haskell developer. I've poked around with Haskell, and so this is more about me learning Haskell than me explaining anything Haskell related from any place of expertise, because I'm not coming from a place of expertise. And the second caveat is that this is an improvised live show. So the idea of the show is every weekday, I jump into a code repository I haven't seen before and dig around. So this is me trying to figure out what's going on in this repo. And again, not me explaining from any place of understanding or expertise what's going on in the repo. So here we are. Let's see. We've got a few releases, actually quite a few releases. And we see that there's a lot of Starlark here, where Starlark is is Google's configuration language, which is essentially a version of Python with some of the features removed. And the features are removed to make the language simpler and less able to do things like have infinite loops, easier for the restrictions are there to make the language easier to reason about from the perspective of a configuration language rather than a general purpose programming language. But we do also get Python and some Shell, and of course lots of Haskell. I don't know what Smarty is, but Nix is the Nix package manager, and we also in the past have done an episode where we looked at the Nix repository as well. So that's what we have here. We have a nice README, including a tutorial and example. And there are links to the website here as well. So looking in the main or root folder, there's a bunch of things like licenses, READMEs. There's a Bazel workspace, I guess, which we might as well look at. And there are some things like stack and stackage, some Nix stuff, and things like Bazel configuration files and GHCI files and some Git stuff. But we're going to ignore all that and see what we can find in the folders. It looks like we can mostly ignore the dot folders. I'll ignore debug and docs. Examples might be interesting. But for now, we'll not look at it. I will look at Haskell. That seems probably like an important entry point. Nix packages I'll skip for now. Protobuf might be important. Tests is always good. And maybe tools. You never know with something like tools. I'll look at the tests first just to get a sense of how many tests we have, what sorts of things we're testing. Okay, so we have a fair amount of test folders, actually a large amount of test folders. This is good to see. How are they doing tests? Well, they've got run start script.sh. So I guess it seems like maybe they're running some of the tests from shell, probably bash. And then we also have run tests.hs. So this is likely using like a test entry point in Haskell. And then we have unit tests and a bunch of folders. I'll just quickly scan the folders to see if there's anything that really jumps out at me. I guess these are probably tests of run files. Here's something about maybe maybe the rules call a stack under the hood, some stuff about REPLs and testing for things like name conflicts. Perhaps this is maybe this was some bug that was found, or maybe it's a name conflicts or a difficult case, and so they wanted to make sure that it was tested. Things about packages like package ID clash, package name. This is all really good to see. Library depths, etc. Different library tests. LHS, I don't know, left-hand side. And just a huge amount. Cabal, Haskell, Cabal, Hackage, GHCID. Yeah, so they must do a lot of stuff here. C2HS. We saw C2HS recently. I guess on Monday when we were looking at the gRPC Haskell bindings. That was another video or episode where we were looking at kind of the Haskell the Haskell ecosystem intersected with the Google ecosystem. And then a bunch of binary stuff, like binary with libdynamic. Let's look at libdynamic and link static flag. I don't know what Asterius is, but I guess we'll skip it for now. And for these, I'm just kind of taking a quick look to see what we have. These are written, I guess, in Bazel. And this all looks really clean. Some stuff about structs. Okay. So, so this is what, unit tests? Okay, so we have, so unit tests only has a few tests, which is fine because we've got what appears to be a huge number of other tests. I don't know if these other tests are not unit tests or if there's something else. Okay, so, and then these tests, at least some of these tests in this folder, this particular one is at Haskell. And what does it do? It declares like as a module where value equals 42. And I suppose that maybe the thing it's really doing is testing the Bazel build file, which would make sense. So let's see if we can find the with libdynamic. Are they doing like dynamic linking? Is that the point of this test? Okay, so we're going to load dynamic libraries and run files test. Is that where we are? No. But we're going to use the dynamic files and run files test. And I'm not sure where it's configured to link dynamically, but I guess maybe in this thing it says to link dynamically. Okay, that's good enough for me for now. Link static looks similar. We've got a Bazel build file, which might be the point of the test. But we've got two Haskell files and a clib. A really simple clib, that's good. And presumably we're going to depend on the clib. Okay, so we've got the CC library, which we'll be using likely the standard Google supplied CC library. And then we've also got a Haskell library. And then what do we get as binary or the test? So the test is going to have the binary as a source. And it's going to depend on both the Haskell library and the C library. And something about hackage base. And then I guess they're going to check that things compile when you have these dependencies. So that's cool. All right, so that's enough. That's enough for tests. Tests look great. Here's the Bazel workspace file. And so I guess not everybody coming to this video will know what Bazel is or have seen my Bazel video. But Bazel is an open source version of Google's internal build system, which is called Blaze. I believe that Blaze is the Bazel source code configured for the Google environment. So there's not like, in some cases for like Kubernetes, let's say, Kubernetes is, it's known externally, for example, that the Google scheduling system thing is Borg, and Kubernetes is not the same code as Borg. It's a complete rewrite of a similar concept. So you do see that sometimes with when Google open sources stuff, but other times, like with Bazel, we get literally the same code. So that's that's kind of the distinction I'm trying to make. And then as is well known in Google, there's a large mono repo that has all of the stuff, or almost all of the stuff. There are, of course, little repos here or there, and some of them are public. Like if you go to probably Google's GitHub page, there will be some source code repos where they might, those Git repos might be actual Git repos within the company. So for some like open source projects, you sometimes get that, but for the most part, all the things you think of as normal Google properties kind of live in this giant mono repo. And workspace is kind of a way to configure the repo root. So I have no idea what it looks like within Google, what the Google workspace file is, but presumably it's large or depends on other files, and collectively they're all large. So what we should see here is basically the setup of telling Bazel what the repo should look like, what this repo should look like. So this is rules Haskell. It is its own repository, and it needs to get built. And then in addition, if you're building your own code, then that will also be a repository, and that will also have its own workspace file. And you might depend on the rules Haskell rules, etc. Okay, so we've got a name for the workspace, and so mainly, I guess I want to see like what are they including? What are they depending on? So they've got something called rules Haskell dependencies. We could probably find that in the code, and Node.js. For some reason, that's maybe a little bit surprising to me. I don't know what they're using Node.js for. Skylib is a Bazel which it's like, I think it's like utility methods. Everything is branded Sky in Bazel. So I think, is that right? Are we using Skylark? Is that what this is called? Starlark. It's called Starlark. Okay, never mind. Forget that. So Bazel Skylib is common useful Starlark functions for, I thought I got like a nice blurb that said a library of Starlark functions. Oh, common. Okay, this is the title. See if you can find that. Common useful functions and rules for Bazel. Yeah. Okay. So this is useful functions, like a library to do Bazel-y stuff. All right. What else? So Cabal. So we're going to download Cabal. And there's a to-do here. Remove when tests are run with the GHC version containing Cabal bigger than or equal to 3.10. And there's some issue. I guess just out of curiosity, that's you get the issue. This seems to be hey, I guess I'll copy this whole line. It seems to be some maybe mismatch between Cabal and rules Haskell. So I'm just kind of curious to see what sorts of things can crop up. So there's a custom Cabal library for when Cabal is bigger than or equal to 3.10. The current version of Cabal has an issue causing generated paths underscore files to miss the definition of split file name and minus file name. And then we link to this other thing, which is another bug. Okay. A fix to Cabal was merged and is planned to be part of the Cabal 3.10 release. So there was some issue with Cabal that caused an issue in rules Haskell, and they patched Cabal. And so once the patch, I guess, is released to the world at large, they can remove some workaround they have here. Alex, I think we've come across before, and I believe is a Haskell Lexer. We look that up? Yeah, why not? Alex is a tool for generating lexical analyzers. Oh, lexical analyzers. Okay, so it's so Lexer stuff. Okay. Maybe they need to understand some source code, which wouldn't be surprising for a build system. And then we've got something about stack snapshots. So stack snapshots were these collections made by the stack people where collections of Haskell packages where all the packages build nicely together. So It's like a snapshot of the Haskell ecosystem. And as long as you stay within a snapshot, everything there should build nicely. And from Stack Snapshot, we have things like Alex, AttoParsec, and ProtoLens Prodoc. I guess ProtoLens we briefly saw in probably the gRPC Haskell video. I believe it's Google's library for generating Haskell protofiles or generating code from Haskell protofiles using lenses. And I say it's Google's project, but I'm like 90% sure it's not an official project. It's more like something that Googlers who are interested in Haskell hacked together and released into the wild. And then we have a bunch of other dependencies. And is there anything that's really stands out? So we see C2HS, which we saw, like, I guess a fair amount of in the gRPC Haskell video, and several common Haskell libraries, but also ProtoLens and Lens family. Temporary, I don't know what that is. Maybe that's a Haskell. I'm going to assume that's a Haskell library named temporary and not like a special cased word. And then we've got setup deps. How are these different from the other deps? So maybe to set up these packages, they need HUnit. And these setup deps have like a Cabal note annotation. So I don't know if this means that these are not in Stack. I would be surprised if HUnit is not in Stack. And we also have C2HS. Yeah, I don't know. Maybe we can take a look at this bug. There's a bug here that's telling us maybe why something is here, either HUnit or polysemi. Remove custom Cabal library. Okay, so it's the same bug. All right. 1871. I'll see if I can remember that so I don't keep clicking on the same bug. Okay. And then I guess what seems to be more configuration for Stack stuff. And then we've got a separate repo because not all platforms support zlib. So a separate Stack snapshot for zlib. I don't know if not Windows. Okay. Yeah. Well, maybe Windows doesn't support zlib. All right, Stack snapshot, more Stack stuff. I don't know why all of these are different. Something about vendor data default instance containers. This is data default IC. And we get a bug on GHC. Recent versions of GHC may fix many max path issues on Windows. However, GHC's loader still exposes such an issue. A fix has been merged in GHC head, but it's not included in 8.10.4 or 9.0.1. So I guess maybe some GHC issue that affects max path primarily on Windows or only on Windows. I don't know what data default OL is. GHC IDE should be like IDE like bindings for GHC. Actually, I think that maybe GHC IDE is like the precursor name for or the name of the precursor of like the Haskell LSP server. So let's look up GHC IDE. A library for building Haskell IDE tooling. It's moved to Haskell language server. Yeah, okay. So it has been merged. It's now a historical artifact. Okay, so this is basically language server stuff with bifunctors. Okay. And they're going to load a bunch of, okay, so Nix packages. So here's more Nix stuff. And then they're going to load rules proto. Nix package local repository. I'm not sure what that's about. Some GHC options. I wonder if that's, I don't know how common it is to configure this in the workspace file rather than in like a Bazel RC file or something, or the configuration for the specific library. But I guess if it's in the workspace, then these are somehow needed everywhere if you're going to use Bazel rules Haskell. So standalone deriving and threaded for linking. Some stuff about Haddock, which I think is a documentation generator. REPL arguments and Cabal options. More stuff about Nix packages and Asterius dependencies. I don't know what Asterius. Let's look up Asterius. Is there an O? Let's spell it correctly, I guess. IUS. Asterius would be Haskell. The Haskell WebAssembly compiler. Okay, and Twig. So it's the same people. Oh, okay, so you can compile to WebAssembly. That's cool. I actually hadn't thought really about whether you could do that. That's interesting. All right, and more Nix packages. I don't know what the Nix packages stuff is doing, but maybe it's similar to the stack stuff. Maybe like it's downloading dependencies and stuff. I don't know. And then more zlib. All right, okay. Maven. So Maven's a Java thing. JVM Maven. So somehow we need, or we might need Java dependencies, maybe. Specifically Spark. That looks like Spark Core. And C2HS repository. Star doc, Bazel star doc, I guess documentation. More Nix packages stuff. Pandoc, Linux, macOS. Bazel rules Go. Rules Go requires Bazel bigger than or equal to 4.2.0. I don't know what Bazel rules Go is used for here. I also don't know what Java is used for here. I have in the past I've been compiling some language that had nothing to do with Go, and there was a dependency in rules Go. So I don't know. This might be a Google thing that somehow pulls in the Go rules dependency. Or also might be somehow rules Haskell uses Go stuff. Okay. Bazel rules contribute rules Bazel integration tests. So I guess integration tests for Bazel, and some stuff for profiling, including Python headers. Okay. Some toolchain stuff. More Asterius stuff and examples. Okay, so there's a ton of stuff there. Some of it's a little bit surprising. Some of it's not so surprising. So I guess probably Stack is not so surprising, although I don't know. Seems like Stack is ultimately calling out to Cabal. I don't know how, I don't know. I don't have a sense of what the trade-offs are in terms of depending directly on Cabal versus depending on Cabal indirectly through something like Stack. Or maybe my mental model of that is entirely wrong, and like Stack is the only game in town for what they're trying to do. But like the Java stuff, I'm not sure if we're gonna see like where that's used. But sometimes with Bazel, because you essentially have to tell it about all of the transitive dependencies, sometimes you get surprising stuff. So although it's a little bit surprising, you expect to see some stuff that's surprising. So modulo that is it's somewhat expected. All right. Okay. So here's let's see. So here's the master/Haskell folder, and we get C2HS Bazel at the top because it's alphabetical order, but that's kind of interesting to see. I guess we'll look at cabal.bazel and cc.bazel, which should be C stuff. Defs.bazel is a common way to name an important entry point. Maybe necessary to name your entry point that way. But we also have things like Haddock, Nix packages, protobuf, providers, REPL, repositories, toolchain. So toolchains are used in Bazel to basically tell Bazel what compiler to use. So the idea is that um, you shouldn't be using the system compiler ideally, well, you will use typically something that's on your hard drive in some sense, but you can configure the compiler in a way that's visible to Bazel, so that Bazel does the same thing every time. So if you had an organization like Google, you would typically have everyone have the same development environment, and so they would have the same like compilers installed or whatever. In other cases, you would do things like you might have your build system have everyone download a compiler from like a server, so that everyone's using exactly the same version. Or in some cases, you might commit the entire compiler binary to version control, so that when you check out the repo, everyone has exactly the same um, binary. So there's stuff like that, and basically tool chains, I believe, are a way of configuring compiler behavior. So it's worth looking at that, because kind of we expect that to be how to configure GHC or any GHC related tooling that you need for building stuff. Private, we're going to look at it just because it's called private. That might be that's presumably like implementation details. C2HS gets its own folder. Platforms, I guess I'm going to ignore. That should be things like, how is Linux different from Windows, and how is Windows different from Mac OS? I guess I'll ignore experimental. Asterius, the idea of compiling to WebAssembly is super cool, but it kind of implies a different compiler than GHC. So that might take us a little bit far afield. So we'll ignore that for now. And then there's this Cabal wrapper thing. I guess I'll look at that. Anything else? Did I open Nix packages? Let's open Nix packages. That should keep us busy. I thought I had more folders open. Suddenly we're in Bazel files. There's private. Yeah, these ones. I thought I opened, here we go. Not sure why the browser reordered stuff, but do this. So look in tools first. Oops. Apparently I won't. No, okay. So here's tools. Just to see what's in here. PyLibrary cannot be put into this folder lest they produce a namespace collision with Bazel tools/tools. See this bug on Bazel build. Python packages are shadowed by Bazel tools. Okay. All right, so what do we have? We've got coverage reports, which is cool. GHC paths. I think we've seen some path logic in, I don't remember if it's GHC or Cabal or one of the other things, but GHC's, I think it does some things like build like full paths into the binary or something. It does something with paths that kind of makes it a little bit harder to deal with path than maybe in other systems. I think. Don't quote me on that. If that's wrong, and you know that's wrong, let me know. But I'm just saying what I think I have seen in the past. We have OS info, which we're going to ignore, in repositories. I don't know, worker, and run files. I'm just curious what worker is. Let's look at main. Okay, so that's just a comment out. So we're importing system stuff, and something about standard out, parse flags. Print worker should be called with persistent worker. And what are we doing? We're erroring out here. Checking some args. Okay, server standard in standard out dupe filter pw flag args. Is server in this folder, I think? So server.hs. There's some server, and it's going to take a handle. It's going to take two handles and a list of strings and do some IO. And the handles are in, I guess, standard in, standard out, and the strings are extra arguments. Then we're going to do a loop and wait for a message. And process request here. and then build a response and log the response, and then go back to loop, I guess. What kind of requests are we dealing with? We got work requests, and how do I find out? Run builder, is that the thing we're doing? So we're going to call run builder ultimately. From data protolens encoding bytes run builder. So is this for, if we're coming from protolens, is this for building protos? Maybe this is a server, like maybe this is like a Haskell server for building your proto files. I'm going to guess so. Let's see if I can find this protolens thing outside of the repo. So where are we? We are in protolens. Constructs a byte string from a given builder. But what is a builder? Builders denote sequences of bytes. They are monoids, where mempty is a zero-length sequence, and mappend, I guess, is concatenation. But what are we doing? So protolens, a lens-based implementation of protocol buffers. Yeah, so I guess we're building protocol buffers. I don't know what else we could be doing. And that's good enough for me for now. So coverage reports is an executable which reads Bazel test.xml test results generated by Bazel coverage for rules Haskell's Haskell test rule. These rules must have coverage report format set to HTML to be compatible with this tool. Okay, so we're going to read, this reads coverage reports and hopefully prints them or does something useful with them after reading them. I'm going to guess it prints them or logs them or maybe gives you an HTML or like a web interface so that you can read them or whatever. Okay, so here's Bazel compatible GHC paths. This package provides Bazel compatible alternative to the GHC paths package. Why Bazel compatible? I guess so Bazel has all this sandboxing stuff, right? So if you've never used Bazel, the way that you get deterministic builds is through sandboxing, and I think more or less what they do is they hash a bunch of stuff. I don't know exactly what goes into the hash, but if the hash changes, you get a new sandbox because stuff needs to be rebuilt. On the other hand, if you're just rebuilding stuff without changing, then you get to reuse all of your previous work, and it's deterministic. So so the paths that Bazel produces are relative to the sandbox, and maybe that's what this is about, because those paths can change and or may not be what GHC expects, etc. So if you use stack snapshot, then you can use vendored packages attribute to replace the package provided GHC paths package by this Bazel compatible version with this thing. Rationale, here we go. Some packages such as doctest, GHC IDE, or protolens protoc make use of the GHC API provided by the GHC package. The GHC API needs access to files included in the GHC installation to initialize a GHC session. In particular, the library directory, that is GHC print libdir. GHC paths is a convenient package that exposes the relevant file paths as Haskell constants. It does so by querying the GHC installation at build time through a custom Cabal setup script and hard-coding the outcome into its sources. This assumes that paths to the GHC installation at build time will still be valid at runtime. This assumption is not generally valid. Okay. In particular, when using a Bazel install GHC bind dist, I think that's binary distribution in GHC language. Bazel will expose the GHC installation to build actions within the sandbox working directory. The path to the sandbox working directory will vary across build actions and will differ from the path at which it is available at runtime. So his GHC paths here, so this second paragraph says some stuff is not valid, and it seems like GHC paths here, the thing that's has an not necessarily valid assumption is not their GHC paths. Their GHC path is like a replacement that I guess doesn't make this assumption. I think. Okay, so this is some workaround for a GHC paths tool. The rules Haskell protobuf just has a build.bazel file. File group all files. True. Glob. Everything. Okay. I don't know what this is doing, but it's creating a file group of all the files, I guess, relative to this subdirectory. All right, C2HS Bazel. So this is a Bazel file and not a build file. So it's going to be some like Python-like implementation. Anything interesting in imports, some CC stuff. Not, I guess that's not surprising. Declare compiled, target unique name. I don't know. I don't know what that stuff is. So C2HS library implementation. We're going to get a Haskell context and get some CC interop info from the context, from the Haskell context. So the context somehow knows, oh, no. From whatever context is passed in. Okay. And then we're going to get an override CC toolchain from the Haskell context. So this interop info takes the original context and also something that knows about the Haskell land, and I guess it's going to somehow return like CC configuration stuff that is going to span the two worlds, the world of Haskell and the world of the C compiler, and then get some args, get the tool chain, checks whether we have any sources. Source field should contain exactly one file. I guess that's because a C2HS library, I guess, should contain one file. That's presumably a limitation from C2HS itself. There's like a single CHS file, I guess. Okay. And then we're going to output a Haskell source file, which is what C2HS does. It kind of like compiles or processes or transpiles or whatever the CHS into Haskell in a way that I guess imports the right C stuff using the FFI, like the base foundational FFI interface. Hang on. Test. Okay. Um, okay, so we're outputting a Haskell source file. We're getting the unique name. I guess we'll declare it compiled, and then we'll add some arguments, like the file CHS file path. Add, I guess, some standard command line arguments, whatever C and -E is, and list the dependent CHI files, and we get them from the deps attribute, and we list the includes. We're going to add them all as arguments, and something about macro headers. Check the attribute version, and then in the shell, I guess we're going to run some stuff. HS actions run shell, and it's going to take as input a bunch of stuff. And the tool is going to be C2HS exe, I guess. So we're going to call C2H. So C2HS has some executable, and I guess what we're doing is we're building up the things that that this needs to know, and we're calling it on the shell. I think. And we've got some command thing. And there's something about mnemonics in Bazel, which I think we looked up before, but I forget what it is. Let's actually look up Bazel mnemonics. Maybe it's there for querying. Am I still logged into Bard? No. Am I still logged into ChatGPT? All right, hang on. Let me do this for a second. Okay, so what are Bazel mnemonics? They're short 1 or 2 letter codes that are used to identify different build targets or actions. These mnemonics are used in the command line interface of Bazel to specify which targets or actions to build. So CC is CC library. I'm not sure this is correct. For example, if you have a C++ binary named myBinary in your Bazel project, you can build it using the following command: Bazel build path to my library, path to my binary, :C. Here, C is the mnemonic for C++ binary targets. Similarly, if you have a Python library target named myLibrary, you can build it using the :pi. Is that right? Let's try Google. So there's, okay. So we have extra actions rules. Okay, so mnemonics are not 2 letters. They have things like Java, C, CC compile, Python. Mnemonics, a list of strings. A list of mnemonics this action listener should listen for. For example, Java. Mnemonics are not a public interface. There's no guarantee that the mnemonics and the actions don't change. Okay? But what are they for? Like, why do we have them? Bazel glossary. Yeah, this is useful. Oop. A short human readable string selected by a rule author to quickly understand what an action in the rule is doing. So it's kind of like a description, but super short, I guess. So it's supposed to be like a human readable string. Mnemonics can be used as identifiers for spawn strategy selections. Some examples of action mnemonics are Java C from Java rules, CPP compile from C++ rules, and Android manifest merger from Android rules. So this is, I guess, if you're looking at a bunch of Bazel output and you're like, what is this thing supposed to be doing? It's supposed to be compiling C. That's the sort of like, I guess, quick sense you're supposed to get from a mnemonic. Okay, so that makes sense. And this looks like a great mnemonic, Haskell to CHS. What I'm confused about though is this run shell thing. So it looks like it's HS actions run shell. Um, I would have thought that Bazel has a way of like a preferred way of executing external programs like compilers that that's built in. So I'm not sure what run shell is supposed to be doing. In fact, I think we saw some of that. I think we somehow traced in one of the Bazel videos to where they ultimately called out to probably Clang. So let's look this up. I'm just curious. Commands and options. I don't know if this is it. Some commands like build or test operate on targets. Yeah. Execute external program. Build programs, commands and options, command line reference. Calling Bazel from scripts, external dependencies. Let's look at, I guess, external dependencies. Bazel supports external dependencies, both text and binary, used in your build that are not from your workspace. For example, they could be a rule set hosted on a GitHub repo, a Maven artifact, or a directory in your local machine outside your current workspace. There are two ways to manage external dependencies with workspace and whatever the module.bazel thing is. I guess it's a newer system. Directory layout, managing external. Okay. But this is not anything about executing. We execute running Bazel external. So let's see if we can find execute. Is run shell a thing? Bazel run shell. There's shell rules. How to run a shell command at analysis time. We have sh binary. Is this how we're supposed to do it? Sh binary is used to declare executable shell scripts. This is for declaring shell scripts. Its outputs aren't necessarily binaries. Okay. Hmm. Now let's try ChatGPT again. So I'll ask it how Bazel ultimately invokes a compiler like GCC or Clang. Yeah, it says it constructs a command line. Yeah. And then it's telling me some kind of like background stuff. Yeah, this is a CC binary. It depends on the platform. Whoever configured ChatGPT to have these like last paragraphs, I always feel like I'm reading like a high school essay. Like it seems like somebody told it that it's supposed to like summarize things with like a really generic sentence at the end. Okay, but so what I want to know is like what is the like what Starlark function does Bazel call to invoke Clang? Is Clang's the name of the compiler, right? Yeah, the compiler front end for LLVM. Well, CC tool. Yeah, well, okay. Stop it. All right. What what in the implementation of CC toolchain, what function actually invokes the compiler? What Starlark function, let's say? Oh, yeah. So it's telling me about toolchains. Yeah, yeah, that's true. Oh, okay. So I jumped the gun. I was thinking it was talking about CC libraries or whatever. So CTX actions run. This looks familiar. Is used to run shell commands. Okay, that's what I wanted to know. Okay, so let's see if we can find this. So actions. We get run here. Let's try just ctx.actions.run in the Bazel search thing. I think I was in the right place. Run. Okay. For actions created by CTX actions run or CTX actions run shell, an immutable list of the arguments for the command line to be executed. Note that for shell actions, the first two arguments will be the shell path and -c may return none. Creates an action that runs an executable. See example use. Okay. All right. So actions run and run shell are the things that are provided. So this is the same name, actions that run shell. So this is presumably some specialization of run shell for the Haskell environment. And so we may see what that is. Okay, I was just curious kind of what why this was different, I think, or rather why it was specialized to Haskell and how different it was given that it's specialized. But it seems like most likely it's basically the same thing under the hood. Okay, so okay, we're still in C2HS. Okay, and then whatever IDIR is, something directory, we're going to maybe include directory, we're going to join a bunch of paths and then return default info. Cool. Then we got this C2HS tool chain implementation. Okay. So it's going to tell us about where the C2HS binary is. You need at least one of these declared somewhere in your build file. Okay, so it's just going to, I guess, be some path to a binary. Okay, so that's C2HS. I thought that was worth looking at because C2HS is almost certainly vastly simpler to GHC. And what we're going to see in GHC is probably like a more complicated version of invoking something on the shell. And so I thought it would be nice to look at how they, how in the same repo, they do a much simpler version of that task. That's why I would spend so much time on C2HS. So here's cabal.bazel. We have get auth, find the .NET RC file and obtain the auth dict with the required URLs. So netrc is used commonly in Unix, at least, maybe also in Windows, to hold authentication data. And so what are we going to authenticate to? We're in Cabal, right? So I guess maybe there's some Cabal. Oh, so okay, API github.com with some bearer token. Why do we need to authenticate? Who knows? Wait, what are the authentication design proposals and the HD? Okay. Yeah, so the proposals they're referring to are from the Bazel, the Google Bazel team, I guess. So maybe this is just in case you need to authenticate to GitHub, or maybe there's some reason that you have to authenticate to GitHub. I don't know. So underscore, not dot, underscore SO extension should be like dynamic libraries. If HS toolchain is Darwin, oh, it's called dylib if it's Darwin. Otherwise, it's called SO. Okay, so this is just like a string, a nice string representation that's conditional on the type of platform we're on. Okay, so some kind of like stringy utility functions in general. Okay, so the Cabal tools are okay. So maybe is Cabal? I don't know if these are part of Cabal or if they are just tools that use Cabal. At any rate, Cabal tools are Alex, C2HS, CPPHS, which might be C2HS for CPP, DocTest, and Happy. Okay, so a blacklist for some of these files, for some of these packages. I guess we can get the Cabal tool flags. Return a -- with prog equals path flag if input is a recognized Cabal tool, none otherwise. And a struct containing the toolchain information needed by the Cabal wrapper, which has things like the archiver. So if running on Darwin, but Xcode is not installed, that is, only the command line tools are available, then Bazel will make AR underscore executable point to /user/bin/libtool. Since we call AR directly, overwrite it. Okay. So I guess we call AR directly. And we have to do some workarounds for that. Prepare Cabal inputs. This is a giant number of arguments. All right. So we're going to compute the Cabal wrapper arguments inputs. So what does it mean by a wrapper? I guess they're going to somehow wrap Cabal in some other thing, maybe a shell script or a Haskell file that will invoke it in an appropriate way that can be controlled and configured by rules Haskell. What sorts of things are they doing? So something about Haskell library dependencies and indirect C library dependencies. Regular Haskell rules perform mostly static linking. That is, where possible, all C library dependencies are linked statically. Regular Haskell rules. Cabal has no such mode. Okay. So what does it mean by regular Haskell rules? Does it mean these rules? Performance mostly static linking? Cabal has no such mode. Since we have to provide dynamic C libraries for compilation, they will also be used for linking. That makes sense? Hence, we need to add run path flags for all dynamic C library dependencies. Cabal also produces a dynamic and static Haskell library in one go. Okay, that's interesting. The dynamic library will link other Haskell libraries dynamically. For those, we need to also provide run path flags for dynamic Haskell libraries. Okay. So we're getting the dynamic libs, and there's something about maybe like a mismatch between what regular Haskell rules wants to do and what Cabal is able to do or wants to do. Executables built by Cabal will link Haskell libraries statically. So we only need to include dynamic C libraries in the run. Okay, so, but it's only the C libraries that I guess are dynamic. But what about dynamic Haskell libraries? I don't know. So there's some setup for run GHC. The regular Haskell rules have separate actions for linking and compilation, to which we pass different sets of libraries as inputs. Okay. I don't know what it means by the regular Haskell rules. Aren't these the regular Haskell rules? The Cabal. Oh, no, as opposed to the Cabal rules, I guess. The Cabal rules, in contrast, only have a single action for compilation and linking, so we must provide both sets of libraries as inputs to the same action. Okay, huh? This seems like a lot of like workaround stuff, mainly around static and dynamic thingamajiggies. When building in a static context, we need to make sure that Cabal passes a couple of options that ensure any static code it builds can be linked correctly. If we're using a static runtime, we need to ensure GHC generates position-independent code, PIC. On Unix, we need to pass GHC both fpic and fexternal dynamic refs. With fpic alone, GHC will generate whatever this is, RX8664 PC32 relocations on Unix, which prevent loading its static libraries as pic. External dynamic refs. Okay, so if you just tell it to GHC to produce position-independent code without this dynamic refs thing, then GHC will generate some specific type of relocations, which won't allow you to load static libraries as position-independent code. I have no idea why, or really even what that means. I'm like vaguely aware what position-independent code is, but this is what sort of thing are we looking at? We're looking at people who understand compilers trying to kind of work around, maybe, who knows whether like this was a great decision by GHC, or maybe this is a thing that GHC did and but isn't as flexible as it could be. But kind of like the rules Haskell people have the job, I guess, of making everything work with the expectations of the Bazel ecosystem and Cabal and GHC, and they are carefully laying out, I think, what some of the like impedance mismatch stuff is, and very nicely giving us comments about what they're doing, which is super helpful. And then if if you're using these rules, you run into similar problems, you'll have a sense of where to look in either in GHC or in rules Haskell to understand what's going on, I guess. On the other hand, if we're building fully statically linked binaries, how's this different so this is for a static runtime. If we're building fully statically linked binaries, we need to ensure that we pass arguments to HSC to HS, such that objects builds are statically linked. Otherwise, we'll get dynamic linking errors when trying to execute those objects to generate code as part of the build. Since the static configuration should ensure that all the objects involved are themselves statically built, this is just a case of passing -static to the linker used by HSC to HS, which will be our own wrapper script, which eventually calls GCC, etc. So there's some wrapper script. This is not the point of this comment, but as an aside, this is super useful information. So they have some wrapper script, which eventually calls GHC, etc. So maybe the thing that they ultimately call, we found out that ctx.actions.run or .run shell is the thing that you're supposed to use to execute an external binary from Bazel. And what they're saying is that the thing they invoke isn't directly the binary like GCC. It's a shell script, or presumably shell script, but a wrapper script is what they call it. Maybe a Python script. Could be any scripting thing, I guess. Probably shell, because we've seen shell stuff here. Okay. I think I understand that. All right, and then we're just doing all the things that we said we were going to do. Basically, here, these are descriptions of why these arguments are the way that they are. And then we have some path arguments about directories, some big struct of arguments, getting the dependencies. So the inputs include are the dependencies. So we have from the input files, and the transitive dependencies from the sources the CC files, the GHC files, package databases. We saw some package database stuff when we looked at Haskell and Cabal, but also a bunch of other stuff, transitive headers, setup libs, whatever those are, haddock stuff. Okay. And then here's the actual Haskell Cabal library implementation. We're going to gather, now that we've seen some of these functions, we have a sense of, I think, what it's going to do. We're going to gather dependencies, get the CC interop info, merge some stuff. All C and Haskell library dependencies are going to get merged. And then separate C and Haskell library dependencies. And POSIX is going to be equal to CTX toolchains from whatever rules sh, I guess shell rules, toolchain type. Check whether profiling is enabled. Get the Cabal options. Find Cabal. Find setup. Declare some files, and it's called package database, so I guess we're getting it from the package cache. We're going to declare some directory, something iface, interface, declare some other data directory. Check if we're doing stuff with haddock or profiling. If we are using a static runtime, the dynamic library will be none. Otherwise, we'll declare this libhs GHC library thing. Then we're going to prepare the Cabal inputs and name it C, which is, C is already, like a single variable name is already a little bit confusing, but in this context, it's super confusing, I guess, because you might think it refers to something about the C language, but I guess this is supposed to be like Cabal inputs. It's going to take all of the stuff basically that we just like marshaled and got together, and then resolve tools. I guess somehow get maybe the tool chain stuff. We know which binaries to call. Declare some more files. We're going to write JSON args to the file I guess we created. So we're going to create some file and write JSON to it. And then we're going to call CTX actions run on the Cabal wrapper using the arguments we wrote in JSON on the file system. And then do this other stuff. And then we're going to get what is default info? So does this output anything? This should basically be, this run thing should not return anything. And indeed, like they're not, if it does return anything, they're not using the return value. But it should change the world. It changes the stuff that's on the disk by essentially running Cabal. But we're also getting default info and HS info and Haskell library info. And we're going to create the linker input. Find the CC toolchains before we create the linker input. Create a compilation context. And call this merge CC info function. Get information about out groups. And then return the result. And the result is just a list of a bunch of the infos. Okay, so that's fun. Okay, so what is it? What did this do? This is the Haskell Cabal library implementation. So I guess if you declared Cabal library, it has to return info so that you can, I guess, import, depend on that library from another rule, like maybe a Cabal binary or maybe a Haskell binary. And ultimately what it did was it got together a bunch of data, threw that data into a JavaScript structure, wrote the JavaScript structure to disk, and then called a shell script with the JavaScript as an argument, as arguments, I think. Okay. Here's some file about cc.bazel is interop with cc rules, and these are deprecated. But here's deps.bazel. This should be some kind of entry point, I think. Note, documentation needs to be added to the wrapper macros below. We've got Haskell common attributes, things like source strip prefix, sources, extra sources, narrow depth modules, label string, run compile flags, GHCI REPL wrapper, GHCI script, GHC wrapper, and worker. Make binary rule generates a rule that compiles a binary. This is useful to create variations of a Haskell binary compilation rule without having to copy and paste the actual rule invocation. Okay. So like a convenience function, I suppose. And we've also got some stuff with tests. It's going to return some rule that's just a binary rule of some sort. Okay, and then Haskell test is make binary rule with test equals true. All right, and Haskell binary is just make binary rule with test equals false. I'm not sure. Seems like this is small enough that you could just use that you may not need this level of indirection. Although I guess the concern might be that they want test and non-test to be generated from the same stuff, with test just having a little bit extra. But it's hard to say. So sometimes things are going to diverge more than you think they will, and sometimes they diverge less than you think they will. So this probably doesn't matter. I'm just kind of thinking aloud about trying to figure out why things are this way rather than some other way or whatever. Okay, so Haskell library is going to be a rule that you give it the Haskell library implementation, and it's got some dict, I guess, of attributes, which I think are just essentially arguments. And here's the Haskell worker wrapper. I'm going to pop the compiler flags. I don't know why. I don't know. So pop should mean we take them off, right? So we're just removing them. And then the defaults is going to be worker select whatever this rules Haskell use worker thing is. And then default update the keyword arguments, and then check, basically switch on the type of rule, whether it's binary, test, or library. And then Haskell binary should be similar. It's the, we get a super thorough code comment, or rather, maybe like, I guess you would call it a documentation comment for, because if you're using Haskell binary rules. And make REPL. I guess you can, I'm not sure what they're doing with REPLs. Create extra attributes for the auto-generated Haskell REPL target. Haskell REPL target. So you get some Haskell REPL target. So a target in Bazel is something you can build target. I assume that's what target means here. And it's auto-generated. So maybe for free, somehow you get like a REPL target, and I don't know what it does. Maybe it creates a REPL. Here's the Haskell test definition. Here's Haskell library. And I think I was going to say, although I'm not sure that I actually said, is that the underscore implementation is usually where the action is. But in this case, we have Haskell worker wrapper is the first thing that we do here. We've got a lot of wrappers. So this one is an implementation. Okay, so let's see if we can find some of these wrappers, like Haskell binary implementation. Is there also a binary wrapper? Is there a, yeah, so Haskell binary implementation is in private. So we'll see that when we go into private. Here's toolchain info. There's not much here to see here. It's just, I guess, we're getting info about the toolchains. Here's the actual toolchain file. Here are the GHC binaries. We have GHC, GHC package, HSC2HS, Haddock, GHCI, run GHC, and HPC. What do we want to see? I guess I want to see GHC and not run GHC. Yeah, let's look at run GHC, at least quickly. So run GHC takes a Haskell thingy, a CC thingy, some inputs and outputs, a mnemonic, arguments, etc., and detect persistent worker support. So I guess worker is about like you have a server, and that's gonna be persistent. So you can keep sending it stuff and it will keep building stuff. Cool. We're going to check if the worker is none, in which case, if it's not none, then I guess we'll say it supports workers. Whatever this prefix thing has got an add sign, we're going to add the worker path, and I guess tools will be whatever hs.worker is. So we'll just add some reference to the worker to the tools thingamajig list. Otherwise, we're just going to add hs.tools.ghc without the worker. XXX, we should also tether Bazel's CC toolchain to GHCs so that we can properly mix Bazel compiled C libraries with Haskell targets. Bazel's CC toolchain to GHCs. Okay. We're going to add all GHC CC program args, I guess, from the Haskell stuff and the C stuff and more C stuff. I guess linker stuff. cc.tools.ld. Okay. Set param file format multi-line. No, don't know what that is. ABI file. If ABI file is none, then we declare the file containing information about the call to GHC with show iface. There's something about interfaces and ABIs. I don't really know what that means in the context of GHC. All right. And then some kind of like more marshalling and setting up. And then ultimately we call HS actions run on some stuff. Like a lot of this is the arguments that we just marshaled. And the executable is the GHC wrapper. Okay. So again, we're instead of invoking GHC directly, we're invoking some wrapper around GHC. Okay. Look up binaries. We'll presumably find the binaries. Haskell toolchain implementation. Is this worth looking at? Maybe. So we're going to check the versions and fail if they aren't what we want. And we're calling underscore lookup binaries, I guess, to get the actual binaries. Cool. Okay, so this is all beginning to look more or less similar from one thing to another, which is good. That's a sign that it's a sign that we kind of have a sense of the flavor, I think, of what's going on. Here's Haskell register GHC bin disks. What is this? Rules Haskell toolchains. Register GHC binary distributions for all platforms as toolchains. Toolchains can be used to compile Haskell code. This function registers one toolchain for each known binary distribution on all platforms of the given GHC version. During the build, one toolchain will be selected based on the host and target platforms. What's the bin dist? Yeah, I think it's like a binary distribution from GHC. Yeah, that's what I'll assume. Okay. What else do we have? Node.js toolchain. Utility rules forwarding various toolchain providers. These rules are used in order to depend on toolchains through the attributes attribute and control their configuration using the CFG field. Okay. I don't know what that means, but maybe it's for people who want to link, somehow mix Python and Node.js. Is it for calling Haskell functions from Node? I don't know why you would want to call Node from Haskell. But maybe one of those things. And then we have things like get CC implementation and other stuff. Okay. Well, here's the Here's the private thing. And we get a bunch of wrappers. Oh, and they are Python. Or at least this one is CC wrapper python.template. So maybe we're doing some templating and then substituting templates or what's the word? When you fill out a template, whatever that's called. Here's Cabal wrapper on top. We've got some actions. Let's peek into actions first before we look at the wrappers. So we compile info, package, process, and run ghc.bazel. Let's compile. All right, we'll look at compile. But let's look at ghc wrapper. Drop loaded and warning. Drop messages that ghc produces on features that we rely upon. Loaded is emitted when using ghc environment files. We use as a poor man's response files for ghc. Warning, the following file is produced when we tell ghc to load object files in the interpreter in the build action of Haskell module, which doesn't do any linking. Okay. What do we do? This is sh, right? This is bash. Okay. This file, the file given as first argument contains the name of the executable, so a path to ghc and some options it uses. So whatever ifs is, something file system, in file system. This is equivalent to read array. We do not use read array in order to support older bash versions. Detect if we are in a persistent worker mode. The file given as second argument, blah, blah, blah. And this thing about must extract ABI. Readable.hi. The fourth argument contains the name of the file in which ABI hash should be written. This is the generation of the readable interface. Compile, show iface, output to readable hi, drop, loaded, and warning. Okay. This last step is to extract the ABI hash from the textual version of the interface. So, hey, we're calling sed. We did a video on sed. We're calling sed to, this is like beginning, maybe space, however many white spaces, and then ABI followed by hash or whatever. And there's too many of these slashes and backslashes for me to try to read this without making mistakes at any rate. And then in the end, we then copy the interface inputs list into an unused inputs list, just calling copy. So if we're in persistent worker, then what are we doing? This runs our proof of concept implementation of a persistent worker. We're calling exec compile flags on persistent worker. But if we're not, then when do we actually call GHC? There's this compile flag thing here. Here's the names of the files passed to GHC. And then we do this ABI stuff. But where is GHC actually called? We generate the call to GHC show iface from the, okay. Do compile show iface. This is just string manipulation, right? I don't think this is actually calling GHC. This is the generation of the human readable interface. Compile show iface. Is this the compilation step? I'm not sure. Let's see what else we have. Let's look at CC wrapper. .py.template. CC toolchain wrapper. Wraps the C compiler of the Bazel CC toolchain, transforms arguments to work around limitations of Bazel and GHC, and passes those via response file to the C compiler. A response file is a text file containing the command line arguments. It is used to avoid command line length limitations. Okay, so there are, okay, so we have some long command line arguments, and we're using a file so that we don't have to pass giant arguments. What are we doing as a template, though? So I see some curly braces here. So I guess we're substituting in workspace and whatever in CC and platform and that sort of stuff as environment variables. Okay. Here's run ghc.bazel. In cross-compiling, we interpret set up the HS in the execution platform. In order to achieve this, we provide run ghc of a toolchain targeting the execution platform. So run GHC wrapper implementation has this Python file as like a here document, I guess. Does this count as a here? No, this is just a string literal, I guess. We're calling subprocess run r.rlocation run GHC, some args and check equals true. Huh. So I guess my my thought here is like these wrappers. I'm not sure why the work being done in the wrappers, in the like the shell files and the Python files, isn't being done in Starlark, because the point of Starlark is to have restrictions to give you things like reproducibility and to make it easier to understand what you're building and to debug and stuff like that and to interact with the sandbox appropriately. It seems maybe a little bit like these files are it's hard to debug or really understand the subtleties of like a templated Python script that that's invoking some shell that's invoking some argument on the shell. And similarly, it's even harder to understand, I think, the behavior or of a of like a of a misbehaving, especially shell script that bash script or whatever. So it seems like maybe there's a sense in which these wrappers are escaping the sandbox. That's supposed to be the kind of the point of Bazel. And what I don't know is one, whether that's standard among Bazel rule implementations. At some point, for sure, we need to call other dependencies. Like we ultimately need to call the compiler. And I think we saw maybe in the Python rules that think that maybe we saw the pattern where they wrote some stuff to disk and then used that file as input to the Python compiler. So assuming all of that is normal, that's fine. But I guess at least my initial thought is there a way to do all of this logic to do more of the logic in Bazel itself, so that we get the guarantees of Bazel. And it might be that it's not possible to do that. It might be possible that it's really hard to do that. So you start with something like this, and then you maybe move more of the logic into Starlark. So that would be a common pattern. So like one thing you sometimes see is like the first generation of rules might do things like under the hood generate like intermediate rules that that configure some stuff, and then like the next generation won't have those intermediately like generated code stuff, because generated code can be hard to debug. Like if you're writing some program and you actually look at what's ultimately compiling your program, and there's like these generated rules that you've never heard of before and you can't debug them because there's no file to go to, then that can be confusing. And so sometimes what people do is they have like a bridge where like that's the easier target to hit, and then you kind of like make stuff more concrete after that. So that is super common. So I don't have a sense of I guess like without a design doc, I don't have a sense of why various design decisions were made. We got a lot of really great comments, I think, in the in some of the Bazel files talking about the like why decisions were made about various flags that were being passed in. There may be some design doc that talks about about the use of wrappers. But I'm going to guess that it's basically that working around limitations or perceived limitations of GHC or other Haskell tooling. But of course I don't know. So if somebody knows, let me know. It's just a a question I have when I'm looking at these files. Okay, so here's actions compile. We import some stuff, a bunch of Bazel. We were in Bazel, right? Yeah. Okay. Compilation defaults. Compute variables common to all compilation targets, binary and library. Okay, so this is some commonality stuff that is factored into, I guess, a function because it's common to libraries and binaries. Stuff like compile flags, some plugin stuff, package info, package IDs. So this is all kind of like standard Haskell ecosystem stuff that we've seen in the various Haskell videos we've done. Transitive libraries dependencies for runtime, link libraries. Yeah, I guess that's the other thing. Like the more that's done in Bazel, the more like later Bazel functions or like Bazel queries. Yeah, I get it. Okay, so maybe that's a concrete question to ask. So like, if you were building something with a Bazel, so let's suppose you were using this, and you had some error, and the error, let's say, is just to blame the user. Let's say the error is because you've misconfigured something with GHC or with Cabal or Haddock, or I don't know what, I don't know if these are all tools that you can configure, but these are all names that we've seen. They're all projects that are involved somehow in this. And you did a query, and it's like your misconfiguration. Then that query might ultimately just point to one of these wrapper functions, like the Cabal wrapper or whatever. And then to get any further information, you'd be debugging like whatever the shell language is, which might not be the end of the world, but that might be you have to like leave, I guess, you have to leave whatever the Bazel tooling is and then go to the tooling language of the shell. And then I'm not sure, but you might have issues around the sandboxes. So like you would have to find some way of like creating a temporary sandbox that reproduces everything up until the compilation step and try to debug it in there. And maybe that's easy to do. I don't know if I've ever tried to like debug within a sandbox. Actually, no, I have. Not in the context of Haskell, but in the context of Python, like the old version of Python rules, I think probably was like alpha. I did have to debug into sandboxes, and that was challenging. But presumably it's easier now that Bazel is more mature and that the rules Python stuff is more mature. So yeah, so I don't know. So that's a concrete question. Like if you would it be better for like debugging for to start moving some of that functionality, bit by bit here and there as necessary, out of the shells and into the Bazel files, or rather by shells I mean out of the wrappers. Yeah, I don't know. Okay, here's compile binary. Okay, so compile binary is an action. Okay, so we looked at rules. So rules kind of define declaratively what something is. So I probably should have talked about all this before jumping into the code. But like a rule for like a Haskell library is like a declarative thing where you say like, here's the source file for my library, or source files. There might be like a bunch of files in a module, and here are the dependencies. And everything in the build graph gets a description like that. And then Bazel's job is to understand those descriptions and build a graph out of it and do whatever DAG stuff that it does, like topological sort, and then build the things in order, that sort of thing. So those are the rules and the descriptions of dependencies, et cetera, et cetera. And then the actions are actions, I guess that need to be taken, like compiling a binary. So compile a Haskell target into object files suitable for linking. Okay, struct with the following fields: object files, dynamic object files, modules, source files, and boot files. Is boot a Haskell thing, or does it just mean? I'm not sure what it means by boot. Bootstrapping in some sort. We can buy a boot. Michael Kors Haskell Combat. What? Unavailable. Curious if Haskell people buy this. This shit. I feel like if you go to a Haskell convention, you need to have this boot. At least somebody does. This one's a bit shiny. They're what, 120 bucks? All right. So if you're watching this and you're a Haskell developer, let me know if you are if you own or know somebody who owns Haskell boots. Okay, so status of HS boot file. HS boot file trick. Oh, whoa. What have I done? Okay. I've used HS boot files in a YSOD project once before. They worked fine. But seems to be a trick. How about this? HS boot. See commentary / compiler / tying the knot. Sounds a very, I'll read this. This seems like an essay. Background reading, GHC at the architecture of open source or applications. I'll absolutely read that too, but not on screen. I'll bookmark it for later. Okay. I don't want to read all of this stuff. Well, just tell me what a boot is. Type checking HS boot loops. Something about bootstrapping, I guess. So I guess let's read this background. There are symbol tables, which are mappings from symbols to information about the symbols in question. GHC avoids symbol tables. Instead, a symbol contains all information about itself. What? A symbol contains all information about itself. Well, that can't literally be true, but I guess you could try to have it contain all of the relevant information about itself. Thus, the data types for Haskell entities like ID, tyvar, tycon, and datacon in class form an immutable cyclic data structure where everything points to everything else. This makes it very convenient for the consumer because there are accessor functions with simple types, such as ID type from ID to type. The downside of these cyclic data structures is that they are difficult to update. Okay, this has two implications. We have to construct this graph in one go using a technique called tying the knot, since we can't update the graph after the fact. It's immutable. And if any of the data in the graph ever becomes out of date, as can occur when type checking HS boot loops, we have to throw out all the in-memory data structures and rebuild the graph from scratch. Is that worth it? But also, what is HS boot? HS boot loop. So some bootstrapping stuff, I guess. Because they have the... Add HS boot. Okay, so we're going to add HS boot files. Let's see what they are. It's just a list of things. All right, let's go to ChatGPT. What are HS boot files in Haskell? Okay, so they break up circular dependencies in modules to forward declare type. So it's like forward declarations. Okay, got it. Okay, so they are some like manual configuration, I guess, to when you know that there are circular dependencies, or was it circular declarations? Circular dependencies. So if module A depends on module B, or module A depends on module B, and module B depends on module A. It's best to just not have circular dependencies, but I don't know if it's always possible to avoid. Certainly, it's sometimes hard to avoid. I don't know if the Haskell module system maybe is it possible that it lacks some of the mechanisms people usually use to avoid circular dependencies, or is it just like a fact of life that sometimes things have circular dependencies that are indirect or hard to see, and so you just have to have some way of dealing with it? I'm not sure. At any rate, we've got boot files in compile. And this should be, I think, straightforward now. We've got a list for coverage data. And we're going to return this struct. And the struct just contains all the stuff, like object files, dynamic object files, source files, boot files, etc. And then compile library should be similar. It should be everything, more or less everything GHC needs to compile something, like all of the kinds of arguments and all of their values. The C2HS just has this build Bazel file, which we will ignore. Here's Cabal wrapper, but it's not in private. Hey, stop with the tooltips. It's not in private. So what does that mean? I don't know. It's like a publicly facing Cabal wrapper, or maybe it just calls out to the private version. Okay, so Cabal wrapper is a Pi binary. Okay, that maybe it was Cabal that had this Python implementation, so maybe that's why it's a Pi binary. At any rate, I don't think it's super important to look at after the other stuff we've looked at. Here's Nix packages. And then for Nix packages, I'm just curious what we're doing. So something about GHC versions, GHC Nix packages Haskell toolchain implementation. So we've got some symlink content of GHC external repo. GHC Nix packages Haskell toolchain. Register GHC Nix. Is this for like getting GHC from Nix? Static attributes. I don't know. Maybe this is something that the documentation will help us with. Let's try the documentation. You are NixOS, skip to the Nix packages section. This rule set supports using Nix packages to provision your GHC toolchain and fetch the package packages from there. Okay. If you are on NixOS, this is the only way to set up your project because the GHC toolchain provisioned through binary distributions cannot be executed on NixOS. Oh, wow. That's a bummer. Huh. Yeah, that's kind of wild. So I guess this is maybe like a workaround for Nix being unable to use the standard GHC implementation. But this kind of creates like a fork, right? So if you are, let's say you're some organization, I guess either everyone has to use NixOS or everyone doesn't. Or if you have some Haskell file, I guess, presumably it's easy to change from the Nix stuff to the other stuff. But that kind of it would be nicest if like everything could use the same stuff, or like you could just have a way to configure your toolchain to use whatever GHC you have. But it seems like there are limitations of GHC that maybe around the file path stuff, and there are, NixOS has its own like package repository, which we saw, which has its own kind of like sandboxing type stuff. And I guess those two things don't like play nicely with each other in some way. And so NixOS can't use the like bin dist, I guess, or whatever GHC stuff. So that seems that doesn't seem like the rules Haskell people's fault. That sounds like something that's like a fact about the world that they're very kindly allowing you to work around in a nice way. And I think that is the end of the line. Let me just double check by closing everything. And I think that's it. I'll do one quick sweep through just to make sure. I don't know why I keep ending up exactly at the tooltip, whereas I didn't before. Maybe I made my screen a little bit larger, so maybe it's just having to do with the screen being different than I'm used to. But I'll try to remember to watch out for that. Okay, so yeah, so examples, Haskell logo, Nix packages, rule info. Yeah, I think we saw just about everything. So that's a really cool project. I think that one of the things I'm going to do next few weeks is try to build a simple Haskell microservice. Probably using the gRPC Haskell stuff we saw. I don't know if it's also possible to use the rules Haskell stuff, but maybe it is. Maybe it's not. Maybe I have to use Nix. Maybe Geeks has support for it, which I doubt. So we'll see how that goes. I haven't built anything on the show before, and I think that would be fun to try to build something in Haskell. All right, so that's it, and thanks for watching, and have a good one.